Every year, American cities spend over $100 billion replacing sewer infrastructure, pipes corroding, joints cracking, systems that were supposed to last a century failing in 50 years. This sewer was built in 600 BC, before the Roman Republic existed, before Julius Caesar was born, before the Colosseum, the Pantheon, the aqueducts, and it is still working right now, today. Rome's sewer has outlasted the empire that built it. Medieval Rome, the Renaissance, 2 world wars, every civilization that has come and gone above it. The arches haven't moved. The water hasn't stopped. How do you build something so permanent it becomes eternal? To understand why Rome built the Cloaca Maxima, you have to understand where Rome was built. 7 hills surrounding a central valley, the Forum Romanum. Every time it rained, water ran down every hill and collected in that valley. When the Tiber flooded, which it did regularly, it backed up into the Forum from the other direction. The political and commercial heart of Rome was, geographically speaking, a swamp. By the 6th century BC, Rome's population was approaching 100,000. That's 100,000 people producing waste every day with nowhere to put it. Open ditches carried sewage toward the Forum, which was already flooding. The Forum Romanum, the space where Roman law was written and justice dispensed, was surrounded by waste. The most important city in the Western world was being strangled by its own geography. Previous attempts had failed. Surface ditches overflowed, shallow trenches silted up, street-level solutions couldn't handle the volume. The problem wasn't just drainage, it was that Rome needed a solution that would work for a city of 1 million people, not the city it was. They needed something that would never clog, never overflow, and never need to be replaced. And they needed to build it underground, which meant engineering a structure that could support the weight of an entire city above it for centuries without failing. The solution was radical for 600 BC, build a covered tunnel beneath the city. Not a surface drain, not an open channel, a fully enclosed underground sewer, large enough for a man to walk through, arched to support the weight above and sloped precisely to move water to the Tiber by gravity alone. No pumps, no mechanical parts, just stone and physics. The material choice was critical. Wood would rot underground. Unbaked brick couldn't handle the water pressure. The Romans used volcanic tuff. A stone quarried from the hills around Rome that could be cut precisely, but hardened with age and exposure to moisture. The deeper the tunnel, the more pressure on the structure. They needed a material that got stronger under those conditions. Tuff did exactly that. And then they made a decision that defines Roman engineering. They built it bigger than they needed. Not for the city of 100,000 that existed in 600 BC, for the city of 1 million they intended to build. The main tunnel reaches over 3 meters across in its largest sections. Wide enough to drive a cart through. That wasn't an accident. That was Romans engineering for permanence, not convenience. Build it once, build it right, never build it again. The engineering secret of the Cloaca Maxima is the arch. and why the arch works underground specifically. An arch isn't just a curved structure, it's a physics solution. Wedge-shaped stones, called voussoirs, are arranged so that the weight pressing down redirects outward into the walls and down into the foundation. The stones are locked in compression. They cannot slide, they cannot fall. The harder you press on an arch from above, the more locked those stones become. Underground, this matters enormously. A flat ceiling over that tunnel would be carrying thousands of tons of city above it. Focused directly downward, it would crack, it would collapse. The arch distributes that load outward to the walls and down to the foundation. It doesn't just resist the weight above, it uses it. The Romans built the Cloaca Maxima with massive stone blocks, some weighing hundreds of kilograms, fitted together without mortar in many sections. The arch itself holds them in place. The arch keeps the tunnel standing, but for a sewer to actually work, you need the right slope. And maintaining that slope is harder than it sounds. Too steep and water flows too fast, eroding the stone channel. Too shallow and waste accumulates, eventually blocking the tunnel entirely. The Romans calculated a gradient of approximately 1 in 100. 1 meter of drop for every 100 meters of horizontal distance. That creates flow fast enough to carry solid waste, slow enough to prevent erosion. And they maintained that gradient over more than a kilometer of tunnel, using tools made of wood and string. Modern surveys of the Cloaca Maxima show the gradient varies by just a few centimeters over hundreds of meters. With ancient instruments, that level of precision underground in 600 BC is not an accident. It's obsessive, systematic engineering, checked and rechecked at every stage of construction. The Cloaca Maxima wasn't just one tunnel. It was the main artery of a citywide drainage network. Smaller channels fed in from streets, public buildings and private homes throughout Rome. At strategic points, vertical access shafts connected the tunnel to street level. Not just for construction access, but for maintenance. Roman engineers knew this infrastructure would need to be inspected and cleared for centuries. They built in the service infrastructure from the beginning. And all of it flows to one destination, the Tiber River. The outfall, the point where the Cloaca Maxima discharges into the Tiber, is still visible today. You can see it from the riverbank, a massive stone arch emerging from below street level, water flowing through it, as it has for 2,600 years. Rome's gravity-powered drainage network, still completing its journey to the river. Construction began with excavation. Workers, thousands of them, including conscripted labor and slaves, dug a trench through the Forum Valley down to bedrock. In some sections, that meant going 4 to 6 meters below street level. They used wooden shoring to keep the trench walls stable during construction. They maintained that precise gradient the entire length. Every meter was measured, checked, confirmed. And the earth they removed wasn't wasted. It went to raise ground levels in other parts of the city. Improving drainage there as well. Once the trench was prepared, stone placement began. Foundation blocks of volcanic tuff or limestone were laid directly on bedrock. Perfectly level, strong enough to carry everything above. Sidewalls rose from the foundation. Then came the arches. Workers built wooden formwork in the exact curve of the planned arch. A temporary skeleton to hold the voussoirs in position while they were placed. Stone by stone, the arch grew. The final piece, the keystone at the top center, locked the entire structure, formwork removed. The arch stood alone, held by compression. And then the process repeated for the next section. And the next, until the tunnel stretched the full length of the valley. As the main tunnel was completed, the network was connected. Smaller drains from streets and buildings joined at carefully engineered junction points, designed to prevent backflow. Access shafts were built from street level to the tunnel. Some drain covers at street level bore the inscription SPQR. Senatus Populusque Romanus, the Senate and people of Rome. Civic pride stamped into the most utilitarian infrastructure imaginable. Then water was allowed to flow. And it worked. It has not stopped since. The Cloaca Maxima stretches over a kilometer through the heart of Rome. At its largest sections, the tunnel is more than 3 meters wide. enough for a cart to pass through. In some sections, you can stand fully upright inside. The stone used to build it represents thousands of tons of precisely cut volcanic tuff and limestone. The complete drainage network it anchored extended for many more kilometers across the city. When it was finished, Rome had the first comprehensive city-wide sanitation system in human history. Every major Roman city that followed was built on that model. For 2,600 years, the Cloaca Maxima has done exactly what it was designed to do. The gradient creates a flow velocity that's self-cleaning, fast enough to carry solid waste, slow enough to prevent erosion. Material doesn't accumulate. The system clears itself. When maintenance is needed, the access shafts the Romans built are still there. Workers can still descend into the tunnel. The Romans designed this to be serviceable for centuries. 2,600 years later, it still is. Think about the timeline. The Cloaca Maxima predates the Roman Republic. It was already ancient when Julius Caesar was alive. It kept working through the fall of Rome in 476 AD. Through 1,000 years of the medieval period, through the Renaissance when Rome was rebuilt, through the Industrial Revolution, through 2 world wars. Empires rose and fell above it. Languages changed. Civilizations came and went. The same stone arches, the same water, the same tunnel. 2,600 years of continuous operation, no major reconstruction, no replacement, just maintenance. Modern cities build sewers very differently. Concrete pipes with rubber gasket joints. Plastic PVC, corrugated metal. And we design these with an expected lifespan of 50 to 100 years. That's not a flaw. It's a deliberate engineering choice. Modern sewers are designed to be replaced. Every few generations, cities dig up their infrastructure and install new systems. It's planned obsolescence built into urban engineering. The Romans made the opposite choice. They spent more up front. They built slower. They used heavier, more durable materials, but they only built it once. And now, 2,600 years later, the calculus is clear. Modern cities have rebuilt their sewer infrastructure dozens of times since Rome built the Cloaca Maxima. The cost of all that rebuilding across all those centuries dwarfs what Rome spent in 600 BC. The Romans built slower, and they built cheaper, because they built it right. The Cloaca Maxima is more than a sewer. It's proof of something. Most of ancient Rome is gone. The temples are ruins. The forums are excavation sites. The palaces collapsed centuries ago. But the sewer works, the most utilitarian thing Rome ever built, designed to carry away waste, outlasted everything else. The glory of the empire is archaeology. The sewer is infrastructure. That's what happens when you refuse to compromise on permanence. When you build for the city you intend to become, not the city you are. when you use materials that harden with age instead of corroding. Rome fell. The Cloaca Maxima didn't, and it's still here, still doing its job every hour of every day, over arches placed by hands that have been dust for 2,600 years. Rome built sewers that have lasted 2,600 years, but they also engineered something even harder: concrete that doesn't just survive underwater, it gets stronger. In the harbour of Caesarea Maritima, Roman engineers poured concrete beneath the Mediterranean and built the largest artificial harbour in the ancient world. That concrete has been submerged for 2,000 years. Modern underwater concrete fails in decades. We still don't fully understand how Rome did it. Next, how Rome built harbours in the open ocean using concrete that defies modern science. That's next on Rome Reconstructed.